In this problem, we're asked to find the hybrid parameters for the two-port network shown below. I want to define our variables first. So here's our voltages, V1, V2, and here are our currents, I1 and I2. And our parameters then, V1 is H11I1 plus H12 V2, and then I2 is H21 I1 plus H22 V2. And our task then is to find those four parameters. We'll do this by, for instance, in one instance, setting V2 equal to 0. That will allow us to find H1 and H21. And then if we go and set I1 equal to 0, that will allow us to find these two. So let's start off with V2 equal to 0. So here's our circuit. We've set V2 equal to 0. And what we're looking for here is V1 is H11 I1 and I2 is H21 I1. Now I'm going to work on this problem using nodal analysis. So let's make that node reference. I'm going to let that node voltage be Vx. And now we want to apply KCL at that node. So we'll have Vx minus V1 over 500 plus Vx over 50 plus Vx over 20K is equal to 60 I1. And if we look at our diagram, I1 is V1 minus Vx over 500, so we'll have 60 times V1 minus Vx over 500. So collecting terms, we'll have 1 over 500 plus 1 over 50 plus 1 over 20K plus 60 over 500. Vx is equal to 61 over 500 V1. Let's multiply through by 500, so we'll have 1 plus 10 plus 0.025 plus 60. Vx is 61 V1. So we have 71.025. Vx is equal to 61 V1, or that Vx is 0.8589 V1. So now we've got Vx in terms of V1. So now let's go in and get V1 in terms of I1, which is where we're working toward. So I1 is V1 minus Vx over 500, which is V1 minus 0.8589 V1 over 500, which is 282.2 times 10 to the minus 6 V1. So then V1 is 3.5436 times 10 to the third I1. So that gives us H11 is 3.5436 times 10 to the third. Now we still need to get to I2, and if we look, we can apply KCL here. If we look at our circuit, this is the voltage Vx. So by applying KCL at that node, we'll get Vx over 20K plus I2 minus 60 I1 equal to 0. So then I2 is 60 I1 minus Vx over 20K. And now we need to make the substitutions. So we have I2 is 60 I1 minus 0.8589 V1 over 20K. And then I2 is 60 I1 minus 0.8589 over 20K times 3.5436 times 10 to the third I1, and this becomes 59.848 I1. So H21 is 59.848. So that gets us those two parameters. Now we need to go in and set I1 equals 0. And this is going to allow us to find V1 is equal to H12 V2, and then I2 is equal to H22 V2. So if we look, I1 is equal to 0, so that tells us this is equal to 0. So that tells us that I2 is the current at that point in the circuit. So if we look, then V2, by applying KVL around this loop, V2 is 20,000 plus 50 times I2. So that's 20,000, 50 I2. So then I2 is 1 over 20,050 V2, which is 49.875 times 10 to the minus 6 V2. So H22 then is 49.875 microsiemens. And then if we apply KVL around this loop, the voltage across here is 0. So V1 is 50 I2, which is 50 times 1 over 20,050 V2, which is 2.49 times 10 to the minus 3 V2. So H12 is 2.49 times 10 to the minus 3.